Now we're going to take a look at application awareness. We're going to start with voice. So we've come down to clients and we've turned on our two phones. And these are using the demo-application SSID, which will be changing to demo-app later, so keep that in mind. And right now the two phones are up, but they're listed as demo-camera for their role. That's the default AAA role for that particular SSID. What's going to happen is, once we go through and launch Asterisk, which we'll do right now, those will actually change roles, and I'll explain a little bit about that as we launch the Asterisk server. So you're going to see some errors as Asterisk launches. That's perfectly normal and understandable, so don't worry about it. You'll know Asterisk has completed its boot cycle when you see the menu come up. We've chosen this particular version of Asterisk, number one, because it's free, and number two, because there's a menu, so you don't actually need to worry about configuring anything. We've done all the pre-configuration to work with the demo kit. Now, what's going to happen is Asterisk will finish booting, and the phones are actually going to go through and associate and register themselves with the Asterisk server. Now, because of the voice license and the way we set up the AAA, what it says is that the initial role for everybody on the PSK is the camera role, which has certain permissions set aside to work. When the phones finish associating, we'll see that registration process go through and we'll change their role to demo-voice. And that has different permission sets and allows voice traffic on a different priority. This is an extension of our user-based network control system, where we're really caring about not only what is the person, but what is the device, in that if it's an unmanageable device, meaning I don't have personal credentials on it, I can still associate a role based on what that device is. So now the Asterisk system is booted. We'll minimize that because there's nothing else we need to do until we actually get around to shutting it down. And as you can hear in the background, one of my phones is already up and running. The phones will constantly keep trying to re-register, and we'll see as soon as this refreshes that their user role will change to that of demo-voice. And we'll see if the next one registers, and its user role also changed. So the only thing that's different between a camera and a phone is the camera did SIP authentication. Now we'll come down and take a look at the voice client itself and give you some idea of what's going on. So both of them are in idle mode, they're registered, and we know what their client is. So we'll come in and do some troubleshooting on this particular client. So we know the client's MAC, we know what its IP is, the client name, what the call status is, what its role is, what protocol it's using, because it can use things other than voice. What we want to do is come up here and set your refreshed every 5 seconds. This allows you to see more in real time what's actually happening. And we'll take a look at a few of the other things. The SIP ladder tells you how things actually are functioning on the system, how we registered and got things going. Your data path will show you what ports have opened. We have a client call record, which we'll look at again in a minute. And then we have some statistics in real time: delay, jitter, packet loss, and as we scroll over, the R value of the actual call, which gives you some idea of what the call quality is. So now we'll make a call inside the room. And you'll see the call is already initiated on the client record. And the first one failed. Go ahead and answer it. So the first one we failed because the phone was not quite ready. The second one we connected to. Now we'll see, as we talk through it, you'll see that now we have a green call quality over here because the call is getting good call signal. We can also see the data path session tables that have opened up, and we'll see in real time jitter and delay there's been no packet loss, and the R value is uniformly high. What this is giving you is the ability to do troubleshooting of phone calls in real time without having to connect to the PBX over the network. And we'll end the call now, and we'll see that the system understands what's actually happening. We've had a successful call. Duration was 49 seconds. We had an R value of 88. Anything over 75 is considered good. And green is essentially just an indicator of what happened, but we know the client name, the client IP, it was an outgoing call, and who we called. What we've demonstrated now is that voice is more than just data. It requires different applications, and you need visibility into those applications to be effective when rolling out a new technology like this. And you don't always necessarily want to have to get the PBX guy installed. If you think it's a network problem, let's find out. The easiest way to do that, we'll pause this for a moment, is the SIP ladder. You can come back in here and see that the station went through a complete setup. We can see what the problem was. If the call fails, we'll see if we can find that real quick. We have some unknown pieces. We registered here, and we know that as we go down the ladder, we'll see that calls succeeded. We hung up, we said goodbye. We can troubleshoot that system. So it's no longer, where am I in the system? Do I need to go get a packet capture out? We're watching the packets in real time. We can tell you what's going on. And that ends the voice piece of this. Ideally, you will let your clients make phone calls to each other during this demonstration. That's really a much better demo than you talking to your buddy that came with you for the sale. Let the clients do the call. We're going to switch to the client machine now, and we're going to show video. And the reason you do not show video on the management station with Asterisk running is simply that Asterisk is a resource hog. So keep that in mind. If you shut the Asterisk server down, no problem, go ahead and show video, but if you try to show both, it's going to look choppy and they will inevitably blame wireless when really it's the PC processor that can't handle it. So we're going to go ahead and switch over to the client station and we'll take a look at video over wireless.